In this lesson we shall be revising the electromagnetic spectrum and the property of the waves. The electromagnetic spectrum is a family of waves. At one end of the spectrum we have radio waves, and at the other end of the spectrum we have gamma waves. The order can be remembered like this. Remember my instructions visible under X-ray glasses. All of these waves travel at the speed of light, which is 3 × 10 to the power of 8 meters per second. The main thing that differs between these waves is their wavelength. Radio waves have the largest wavelength, which is the distance between one crest and the next. At the other end of the spectrum, gamma waves have the smallest wavelength. A wave with a small wavelength will have a high frequency, which is the number of waves passing per second. So gamma waves have the highest frequency, whereas radio waves have the lowest frequency. This makes gamma waves very energetic. There is a lot of energy in a small amount of space, whereas radio waves have less energy in the same space, so they are much safer for cells. All the waves in the electromagnetic spectrum travel as transverse wave. In a transverse wave, the direction of energy travels at right angles to the direction of the wave. If you were to look at one point on a wave, you would see that that point simply moves up and down as the energy passes across. All members of the electromagnetic spectrum pass at the same speed, which is the speed of light. This speed is 3 × 10 to the power of 8 meters per second. This diagram shows clearly the various parts of a wave that you need to learn. The peak of a wave is what we call the crest. The bottom of a wave is what we call the trough. Half the distance between the crest and the trough is what we call the amplitude. The number of cycles of waves passing per second is what we call the frequency. This is measured in hertz, Hz for short. The distance between any two equivalent points, for example, the point of a crest and the next crest, is what we call the wavelength. If the wavelength is smaller, there will be more cycles per second, therefore the frequency will increase. All the waves on the electromagnetic spectrum share the same basic properties. Property number 1 is reflection. An electromagnetic wave can be reflected from a shiny surface, for example, like a mirror. If we mark the incident ray, which is the ray coming in that strikes the mirror, and the reflected ray, which is the ray that reflects from the mirror, we can work out the angle from the normal. This is marked as a dotted line on the diagram. The basic rule of reflection is that the angle of incidence is always the same as the angle of reflection. Property number 2 is refraction. When a wave enters a different medium, its speed will change, causing refraction. In this case, the light wave is passing from low density air to high density glass. As the wave enters the glass, the wave will slow down. This will cause the wave to move towards the normal. As the wave leaves the glass, the wave will speed up again. So now the wave will move away from the normal. The third property of electromagnetic waves is diffraction. Diffraction can occur when a wave passes through a small space. As the wave passes through the space, the wave can pass through and spreads out. Waves with a longer wavelength are better at diffraction than waves with a shorter wavelength. So, for example, radio waves are very good at diffraction, whereas gamma rays hardly diffract at all. The smaller the gap they pass through, the greater the diffraction will be. If the wavelength of the waves is less than the gap, diffraction will not occur. In other words, the wavelength has to be at least equal to the size of the gap for diffraction to occur. Diffraction can be very useful. For example, due to diffraction, waves can get around buildings. Radio waves are extremely good at diffraction due to their very large wavelength. Let's imagine two hills side by side, a west hill and an east hill, and let's imagine that a house was found behind the east hill. As the radio wave passed through the gap, it would diffract around both hills. So the owners of the house would have very good radio signals for their radio music, despite the hill being in the way. Unfortunately, microwaves are very poor at diffraction owing to their small wavelength of only a few centimeters. So microwaves would not be able to diffract around the hills. This could lead to poor microwave mobile phone signal reception of people living behind the hill. Diffraction can be a problem. In a microscope or a telescope, the light has to pass through a small eyepiece. This will cause diffraction of the light waves, which will cause distortion of the image. Diffraction also takes place around edges. This can cause a problem in transmitter dishes, because as the wave passes over the edge of the dish, it will diffract, causing the wave to spread out and to weaken the wave.